Hi, my name is Adrienne Groff, and this is my reverse engineering project. So the item that I chose to do my project on is just a standard floor fan. A lot of schools have these, especially if they are still running without an air-conditioned unit. But you can also buy these at Walmart for fairly cheap. Typically, the cost of these is anywhere from a $20 to $40 range. Just kind of depends on where you find them. The one I have does have different speed settings, so that obviously increases the cost of them as opposed to ones that have just one standard setting. So the whole purpose of a floor fan is to obviously help you keep cool in the summertime heat. And then the overall shape of the fan, because it is so large, it kind of helps provide that more cooler air and help move that more cooler air into the room. Because you can easily sit this object in the windowsill and kind of bring cooler air into the house. As well as obviously, on the hot summer days where your home or your room is specifically hot, it'll help move the hot air around so it's not stagnant in one spot. And ideally, as long as you're within the line of the fan, you will feel a bit cooler than you would if you were not in that line. So ideally, the shape of it just helps with sitting on the floor specifically or sitting in a windowsill area. So you can see in these 4 pictures, these are the main parts that you see. So the first is obviously the aluminum frame that's here, and you can see inside is where the fan motor would be. Then the propellers, they are obviously plastic. Number one, because they need to be lightweight, as they will be changing different speeds, but they also need to be able to cut through the air and move the air around faster than most other material, which is why plastic is used for the lightweight feature. And then ideally the shape of the propellers is very similar to what you find in an airplane model, helicopter model, and even in boats, just because they kind of help cut through the air or water for boats better than other shapes. Then there's the 2 plastic outer casings as well. Obviously, it has the holes in it because the air would be running through it from the back to the front. And then, although you can't see it well in this picture, there is a little ventilation portion that would go right in front of the motor, which would help kind of cool the motor off so that it wasn't overheating in any sense of when it's working. So this is the overall motor. It's made out of cast aluminum. So it's a motor enclosure basically. And you can see it's where it hooks up electrically from the outlet. This piece would not budge, so I don't know if it actually comes out at all. I did attempt to pull it out, but it didn't really do too well. So I have a feeling that it's probably not supposed to be removed. So that's obviously where the electrical current would run through to then obviously move the interior portion to kind of move the propellers. The piece at the other end, that's kind of a white piece sticking out, that is actually where the knob sits on top. So the knob would be on that, which would then turn the different levels of speed in which you can have. So you can see the wires here kind of help make that movement and kind of provide a faster electrical current versus a slower one, depending on the speed in which you choose. So overall, this was a pretty easy project to do as far as undoing it all. It was basically just screws around the outer frame, and then there were just screws right here around the outside that we had to pull apart. So it was pretty easy to do just with our normal screwdriver. So this is then the interior of the motor. So as you can see, this is just the top part that was sitting on top that was easily removed. And then you can see down into it. So this is the side where the wires are is where the actual knob would be on the other side. And then you kind of see it's almost like a hamburger in a sense, where the copper wires are kind of like the buns, and then this metal plate is kind of like the burger in the middle. And then also in between the metal plate and the copper wire are these diodes. So diodes are the material is a mixture of plastic, metal, and aluminum. And they're there basically to amplify electrical current flow. Then the copper wire, obviously it's used, number one, it's a cheap metal to use when it comes to manufacturing purposes, but it's also more conductive than other metals. And the reason that it's wound and very thick is due to the fact that copper in general has a fairly low melting point. So if it was just one strand, obviously the spinning power that was happening would conduce more heat to then snap that copper wire. Same with the electrical current running through it as well. So what they do is they wind it up, and therefore it kind of increases that melting point. So ideally there's a less of a chance that it's going to snap when the electrical currents are running through it. So you can see it's all kind of held together. And then this middle blue part, which is also shown over here on the right side, is where it sits kind of in the middle, kind of goes through the middle of the whole copper portion. And ideally the electrical current and the diodes kind of amplify the magnetic fields. And that's what will then turn this piece to then turn the propellers. So it's all kind of through a magnetic force. And you'll see that better on the other side, or on the next slide, where the picture is of the actual magnets that sit in the middle here along the metal plate. So this just gives you a side view of the metal plate with the copper wires and the diodes on each side. And then it was kind of unique how there were like almost like zip ties, but then this material, it almost looked like a straw, but obviously with all the heat and electricity running through, it wasn't a straw plastic in that material. It was actually a little bit tougher of a material. I don't know exactly what it was, but it was definitely not just plain plastic. This picture on the right, although it's a little blurry, the two copper wires you can still see, but then in the middle you kind of see these little plates all around, and that is actually where the magnets are. So these are all magnets the whole way around, and that's kind of what, like I said, causes the middle portion to do its spinning and move the propellers. So overall, manufacturing wise, it's pretty easy to manufacture. The most intricate parts were the actual motor aspect, but other than that, it was a couple of screws here and there and you're done. So I found it pretty easy. I was actually able to put it all back together, which was good because I might need it as I'm moving into a new house soon. But that is my reverse engineering project, and hope you enjoy.